Okay, hi guys. So in this video, what I want to do is I want to actually solve a polynomial equation using the fundamental theorem of algebra. Now, there are a few ways to do this. Since I have not gone over synthetic division yet, I'm not going to be doing this with synthetic division, because I know that's one way you can do it. Okay, so, yeah, so I'm not going to be doing this with synthetic division because I have not gone over that yet. But I am going to be doing this with, just evaluating. So, first I'm going to just, basically what the fundamental theorem of algebra says. I'm going to just explain really quick what it says. Because basically, you have to know what it is before you actually learn how to do it. Give me a second, guys. Hold on. Okay, so I know that the fundamental theorem of algebra is something actually very different. What the theorem says, actually, this is not using the rational root theorem. That's going to be, honestly, it's not the fundamental theorem of algebra, it's the rational root theorem. My bad, guys. I said it was fundamental theorem. It's actually rational root theorem, or the rational zero theorem if you want to say it that way. But that's what we're going to be doing in this video. However, you don't have to use synthetic division if you don't want to, unless they do ask you to do that. Because basically, for these problems, I mean, you can just evaluate. What the rational root theorem says, it says that, let's see, hold on. Okay, so, what this is saying here, I know that it sounds really complicated, so basically I'm going to read it to you. So it says if p over q is a 0 of f of x, then p over q is a rational root such that q does not equal 0, and p is any number in the interval negative infinity to infinity, where they're both included, and q is only in the intervals of negative infinity to 0 and 0 to infinity. Okay, so I'm going to explain that part. So what that means is that we can have any, so let's say that we have f of x equals ax to the n plus bx to the n to the m plus cx plus d, da 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 da. Okay, so such that n is greater than or equal to 0, and yeah, so basically what this is saying is that okay, what this is saying is that basically we can have any, so we can have any rational root as long as, so basically if I have, let's say, 2x squared plus 3x minus 1, p equals -1, q equals 2, okay? That's what this is saying. I mean, honestly, you can have, so basically, and that means that you would say the factors of -1 over the factors of 2, okay? Now, that's basically what this is saying, and we would have to go over some examples to know how to do this, because honestly, yeah, so looking at this example, basically, we have x to the fourth, and I just wanted to really briefly explain this because I know this sounds really complicated, but once you see how I do it, you're gonna understand what I'm talking about, because, or hopefully you understand what I'm talking about, because honestly, it's really hard to explain without actually doing an example. Minus 16x cubed plus 86x squared minus 176x plus 105 equals 0. Okay. Okay, so here we want to find our roots. Okay. Now what you're gonna do is you're going to grab the last term, this one, and you're gonna grab the first term, okay? We're gonna say P over Q. This is factors of P and over factors of Q, okay? And the ones that are P and Q, we're gonna call, so this is gonna be factors of P, and then this one is going to be a factor of Q, okay? Now, honestly, this topic is very, I just wanted to bring this up. This topic is really, it's pretty complicated only because it's really long. Like, it takes some work, is what I'm trying to say. But, you know, basically that's why I'm really wanting to go very slow on this one, because, you know, I don't want to just do it all over, and, you know, it takes me time even to do it. So what you're gonna do, you're gonna do the factors of 105. So P is going to be 105. This is your last term, okay? Basically, you're doing the factors of your last term over the factors of your leading coefficient, which is your first term, okay? Your first term is going to be 1. So you have factors of 105 over factors of 1, okay? Okay. So if y'all remember, if y'all used to do like this kind of, you know, this t-chart, and y'all would say, oh, it's, you know, like y'all would multiply 1 times 105, and then you would say 2, is that a factor? Nope. 3, is that a factor? I think it is. So it's basically, so you would do, so if you do 35 times 3, I think, yeah, so it would be 3 and 35, 5 and 21, and then it would be like, you know, I don't think 6 is 1. Basically, you find your factors of each number, but except there's one thing, you have to put plus or minus because it's the positive and negative part. I'll explain more once I write them down. But yeah, this is honestly one of the, it's a tedious topic to actually go over. So if we divide it, we get, okay, so this isn't a factor, and then if we do 105 divided by 7, we get 7 and 15. If we do 105 divided by 8, And I can actually just use my calculator here. 105 divided by 8, that's not a factor. 105 divided by 9, that's not a factor. Okay, so I think we have all our factors now. So what you're gonna do is you're going to write down all your factors. So you have, that means that all of these are factors, okay? They're factors of 105. However, what you're going to do is you're going to include the positive and negative factor. You're going to say, and maybe if I can color code this so that you guys can understand what I'm talking about, just so that I don't confuse anybody. Okay, so all of these are factors of 105. We're gonna say, so the ones that are highlighted in green are factors of 105. We're gonna go ahead and say that, so it's going to be plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 7, plus or minus 105, plus or minus 35, plus or minus 21, and plus or minus 15. Now, you're going to do a division symbol, so you're going to divide it like a fraction. So basically, like this. Put all of these over, and the bottom part, the factors of 1, they're just plus or minus 1, because it's 1 times 1 and negative 1 times negative 1 are equal to 1. So those are the only two factors. The common ones. What you would say is that the possible roots are, so it would be, we would say the following: plus or minus 1 divided by 1, and then plus or minus 3. Since they're all over 1, I'm just going to put every single one like by itself. So we have plus or minus 3, plus or minus 5, plus or minus 7, plus or minus 105, plus or minus 35, plus or minus 21, plus or minus 15. Okay. Now, what you want to do now is you want to test x values by evaluating. That means that you want to test, so test f of 1, and you're going to do this until you see that it equals to 0. Okay, what I'm going to do is this is my function, f of x. Our function here is f of x equals whatever we have up here, x to the 4th minus 16x cubed plus 86x squared minus 176x plus 105. Okay. You're going to test f of 1, f of negative 1, f of 3, and so on, until you see that they're actually equal, like they're actually equal to 0. And once they are equal to 0, if it is equal to 0, then you can actually say that it is a root. So we're going to do f of 1 first. So f of 1, that's going to be 1 to the 4th minus 16 times 1 cubed plus 86 times 1 squared minus 176 times 1 plus 105, okay? You're gonna do, this is equal to 1 minus 16 times 1 plus 86 times 1 minus 176 times 1 plus 105. Now you can use a calculator if you want. I don't really mind using, like, doing it without one, unless the number is bigger. Since it's just 1, it's not really that bad. So we have 1 minus 16 plus 86 minus 176 plus 105. This is negative 15. 86 minus 176, if I use my calculator here. So 86 minus 176, that's negative 90. Plus 105, this is, so we have negative 15 minus 90. And you see that this is equal to 0, so x equals 1 is a 0. However, that's not all we're doing. We want to do f of negative 1 as well to see if that's a 0 as well. So we're going to do f of negative 1, so you're going to evaluate negative 1. And like I said, guys, this takes long, okay? I don't think that in algebra they would make you do this. If they do, I'm sure they have to give you a lot of time for it, because it takes practice, but it's also very time consuming. So we have times negative 1 cubed. So let me write it down really quick. Okay, so this is 1. It's going to be minus 16 times negative 1 plus 86 times 1 plus 176, because this is negative 176 times negative 1 plus 105, okay? 1 plus 16 plus 86 plus 176 plus 105. Now, I don't really have to finish adding this because they're all positive numbers. This does not equal 0 because they're all positive numbers. It's going to add up to a positive number. So, knowing that x equals negative 1 is not a 0, okay? We're going to do f of 3. Okay, so we have f of 3. Now this is where you actually want to use your calculator, because honestly, if you literally do what I just did over here for all of them, it's only going to make it a lot more frustrating. So I really recommend that you guys use your calculator without graphing, of course. If you do press to test mode on your calculators, because yeah, honestly with these, this method you can do if you really don't want to do synthetic division, or if you are not good at synthetic division, but I would not, like, honestly, I would not recommend this like method for every single polynomial that you do, because it's going to take a really long time, okay? Anyways, we have 3 to the 4th And actually, you know what, let me put, hold on guys, let me put Desmos really quick so that I can show you guys what I'm doing. Okay, so f of 3, so we have 3 to the 4th, and then we have, let's see here, minus 16 times 3 cubed, and then plus 86 times 3 squared, minus 176 times 3, plus 105. Okay, so you can see here that it equals 0. So we know that f of 3 equals 0. X equals 3 is a 0 of this polynomial. So now we do f of negative 3. If we go back and plug in negative 3 for all of these, will it give us the same answer is what the question is. So, no, it's 1920. So x equals negative 3. F of negative 3 does not equal 0. So x equals negative 3 is not a 0. Let's see. F of 5, if we do f of 5, negative 16, or, excuse me, 5 to the 4th minus 16 times 5 cubed plus 86 times 5 squared minus 176 times 5 plus 105. That's a 0. So we know that f of 5 equals 0. So, okay, so x equals 5 is a 0. Okay. So next, we already have 2 zeros here. Or actually 3 zeros. There is one thing you can do now. You can keep looking for rational roots, like test every one of them out, or test plus or minus 7 or negative 5 as well. Or you can do polynomial long division to find the other factor. Okay. So the following zeros that we have are x equals 5, x equals 3, and x equals 1. We're missing one more. Like I said, you can still keep doing rational root theorem. However, if you really know how to do polynomial long division, I would also recommend that. In this case, since we've already been doing rational root theorem, I'll just finish it off with rational root theorem. So we already tested f of 5. We're going to do f of -5 to see if that's a 0. Okay, so if I just replace every part with -5, hold on, over here. If I just replace every part with -5, we can see that it's not a 0, okay? This does not equal 0. So f of -5 does not equal 0, so x equals -5 is not a 0. Okay. If we do f of 7, so f of 7, so if we just replace everything with 7, and like I said, you can use a calculator for this because I know that it's pretty frustrating, or it's pretty lengthy to actually evaluate every single part. So okay, so x equals 7 is a 0. Okay, so now, and we had a polynomial of degree 4, that means that there's only 4 real solutions to this polynomial. Okay, so the solutions to this polynomial equation are x equals 5, x equals 3, x equals 1, and x equals 7. And these would be your final answers to this equation. Okay. Okay, guys, so, yeah, so that is how you actually do this equation. Now, I know this was really lengthy. Yeah, I really wanted to explain this part, though. This part here, for those of you that are barely heading into doing these, you need to first understand what this part means, specifically this entire part here. Once you understand what it's asking for, and I just did an example just to show you guys how it works, but that's kind of the whole idea behind it, is that you want to do the factors of the last term divided by the factors of the first term. It gets a lot harder once you do with imaginary numbers and stuff, but I mean, honestly, that I'm gonna do that in another video. That's a whole nother concept that, today I'll do it in a different day, but I just wanted to introduce to you guys how to do a basic polynomial how to do a basic polynomial equation with 4 real solutions. So if you guys have any questions about this part here, so yeah, if y'all have any questions about this part here, that the whole thing about the whole theorem that I just introduced, which was over here, this part here. If y'all have any questions, y'all can comment down below. Also, please do like, comment, and or subscribe for more math content. I do algebra, pre-cal, and trig, and I also am going to start very soon on Cal 1. And only recently started on geometry. But yeah, so please do leave a like, comment, and or subscribe. And if y'all have any questions, comment down below, and I will see you guys in the next video. Bye, guys.